downtown Mill Bay. Excellent. And we were up to here, and there, and there. Did we not finish that? Oh, you had it for homework. Excellent. Everybody come up and fill in 2 of the blocks. First come, first church. Church. Nah. Oh no, you get 5 minutes right now. No, 5 minutes to finish it. If you're already done, you can come up and fill any 2.
Can we? Where's the marker?
Go to the writing machine. Is it writing? You need to select. Yeah, there you go.
I was going to do a whiteboard.
What color you want? Oh, oh God.
Wait,
Yeah. Do not use a whiteboard marker on my TV.
Can I have a marker?
Also, don't use your nail fingers, just because. And only 2 people can draw at a time, otherwise the system gets confused, apparently. There you go. Once you've put in your 2 blocks, you can pick any 2. And you could be working on it right now. You're right. Because we had it on Saturday.
You can go. 2
Yeah, you
people
can
at a time.
do 2 people at a time. Oh, honey.
Yeah.
I think so. Let's go.
Hey.
What's your question?
It's erasing right now.
That was interesting.
I think
Does somebody have Julian's calculator?
it's not that one. This one. There. Yeah.
Oh, no. Race.
Oliver.
Race.
I don't see a calculator.
No, not that one. That's the highlighter. That might be the right one. Oh my god. So it's that one there.
Okay.
That was confusing.
Did you also get 35.5 over? Oh, calculated it.
I did.
Okay. It's gonna write that one. Uh-oh. Is that there? Yeah. Okay. On it.
I'm gonna pay them down now for this.
Did you get 6.9 for this?
Pardon?
Atomic math.
No. You can write it whatever you want. It's only loud.
I'm just figuring stuff out now.
Yeah,
If I was writing better, you don't have to.
That was fun.
Is there? Wait, there's a back button.
Neon 22. What did you do?
Oh.
I don't know.
Press HDMI1. No, you're fine.
It's the same. It's like different. It's the same element with different. They're like way more. Like
Oh, that's what neutrons do.
yeah.
Wait,
You can just use your finger to do it.
what's regular?
I'm just filling in like 10 things because no one else wants to do it.
I'll join you. No, it isn't.
What's normal?
Oxygen 16.
And what's different between oxygen and 18? Like if I breathe oxygen, 18 will explode.
Chemically, is it?
Some of the.
It could be radioactive.
Oh.
Yeah.
Some
But
of
we
the.
don't care about that.
But you wouldn't die from eating it.
Yeah.
Do you wanna join our class?
My question was answered.
You can check my state.
Today, I had a chat with my friend Dr. Wallace about lying to students for pedagogical reasons, and I bring up the classic example, which is of course.
Hold on.
Bro, what? What the fuck are
Well,
you doing?
'cause
Bitch?
Hold up, stop
every
writing.
model is a lie.
Bitch?
So there's no guarantee.
Shut up, Jojo.
I'm currently saying it's true.
Dude!
I can't remember if it was a scientist book, but they said there are no true models. There's only more or less useful.
It's also a math course. We have no guarantee that that's how numbers work at all. It's just
Selenium
like,
something.
naively assume it.
I have no idea how to figure out which mass number I'm doing for selenium.
I think it's 0.
I did
Because you can't get it without it being given to you, and it's not given.
I'm 37 too. For what?
Doesn't matter.
Because the average is
They do our
75.
chemically just say someone asks, like, if you
Yeah.
drink heavy water with hydrogen too,
I
and
guess
you manage to
maybe.
replace
Yes,
all the
that's
water,
probably it.
then it might actually happen. Probably not. But if all the atoms
Wait,
are a
what's
little
the mass
heavier,
number
a
for
little
selenium?
slower, that might affect the
79.
enzymes.
The average.
Average.
Yeah, but like you can have equal numbers of 78 and 80. Like hydrogen, there's 3 different types of hydrogen,
Yeah.
and that's just
Yeah.
meant as 1.0 because almost all of them are
Well,
1. Like no neutrons, sorry.
doubt they work. Because
Oh, whatever.
they would not have that.
It's either 0 or 79.
I'm just filling in basically
Like
everything
you
I
say,
can
oh,
right
it's
now.
just glass. Yeah, that's hundreds.
Whatever Jojo did.
Don't
They
even
have
do
to separate
anything.
the ice
Did
from
this.
hydrogen to heavy hydrogen.
What the f-
Add it to water.
Hold up
By
a
the way,
sec.
there's an eraser. You don't have to-
Or
One of
separate
these
it
is
out
an
from
eraser.
regular water where it's like parts per billion.
Also,
So,
does it do like the spinning thing you said? Like,
yeah. So like both those are highly, so
What
it's,
the heck?
I don't know what the going price is, but it's really
Oh.
expensive. A professor
used
when
a
I was
line.
looking at,
So it can be raised.
he put a
Should
drop in my
deflate
tongue, because it was also consumable grade, because they used it in
Hold
their
up a sec.
experiments, and they would also use it to, dissolve things in and inject them into people.
So
And those
line,
injections were
line,
long.
line.
And then as part of a rite of passage, you got to drink some,
Not this
one drop, and I can report that it tasted like water.
Wait, what?
What have you done? Stop all the things. No. Touch nothing. Touch nothing.
Wasn't me.
Oh, hold it. I got it. There's all sorts of things happening now.
Wait, who motive? Oh, you have mass.
Like, use trigonometry on
How do we get rid of that massive line?
Oh.
I think still.
No, it's still there.
Yeah. When there we go. Pre-compressor eraser.
Yeah, we tried that.
No, we can't.
Oh,
It's probably
you
used
oh
a
you
lot.
put it in there. So here, I'll do it. Just because explaining, you don't have to learn how to use this in order to get rid of it.
Lithium 7 is not 3. I don't think. Oh, lithium 7 is 3.
Yeah.
Wait, I wrote that in. Wait,
Uh-oh.
we should just use a different color and write on top of it.
Yeah.
Yeah,
Let's do it on top in red.
Neutrons. It's weird.
no, for like,
But, bro,
Huh?
like the weird they would use in Spanish
Yeah.
and pi.
wait. Red.
When you're red, so you
Oh, okay.
What is the word they use in Spanish?
You know what? You can still
It
read
doesn't
it.
matter.
You can still read it.
Yeah.
There's also the one that's a question mark with an exclamation mark, both in the same thing.
I don't think technology's taking over.
Yes. I like it. It's new. It's a tarot guy. Sounds
For my
cool.
Spanish test, I'll
Can
literally
read it. Doesn't matter. Three.
What's the number of neutrons for this one?
First he had to erase the
Oh wait, never mind. I got that.
Okay, you got it.
We got something weird.
Yeah.
He's doing well, and we're going to encourage.
How did we get the atomic mass number was 79?
If you don't know, I just picked the average one.
What did you just do?
No.
You're drawing with your paper.
Okay.
Hold up.
Go
Really
to
done.
the engine machine.
Middle one. Covering it.
Last chance.
I forgot to write the parts. I think that's
Okay, I think I filled in about 20 boxes.
Excellent. No. That doesn't have a thing. It's just magnetic. No, not over there. It's not. It's only here with a little. Oh yeah, well, we got to get going. Okay. Have your table out. Let's check it. 8, 17, 15, 6, 10, 34, 3. Let me know if you see any mistakes or compared to yours. 8, 17, 15, 6, 10, 34, 3. Looking good. These should all have decimals because they're taken from the periodic. 16, 35.5, 31.0, 12.0, 20.2, 79.0, 6.9. Mass number. Here's where the rubber hits the road. 18, 58, 31, 13, 22, 79, and 7. Excellent. This is the proton plus neutrons. So if you have the atomic mass that's the average, like 35.5, you don't use it if you have the number of neutrons, which in this case we got it from 58. Yes?
For the selenium
Yes, for that one I didn't give you the number of neutrons, so then you do take it from the average.
Okay.
Yeah, so if you don't know, then you use the average. Number of neutrons, 10, 41, 16, 7, 12, 45, and 4. Number of electrons, 8, 17, 15, 6, 10, 34, 3, 18, 58, 31, 13, 22, selenium 79, and lithium 7. Excellent. Okay, turn to the next page. We're going to talk about charges. And I'll quickly do attendance at the same time. Perfect. Okay. We've got, let's see, yes? Oh, I have not given the rules for how to ask for that in the classroom yet? Okay, if you have to go to the bathroom, leave your phone on the desk there and then go. You don't have to ask. If you're only going to be gone 5 minutes or so, you can just put it down and go. If you're going to be gone longer than that, then you have to tell me. If you're like, I'm going to go to the bathroom and then I'm going to go and get some water and then I'm going to go visit with Miss Hanley in the library and then I'm going to go talk to Miss Allen about my course stuff, then you have to tell me because then you're going to miss a lot of class. But if you're going to the bathroom, then you don't have to ask. Yep. Because technically I'm supposed to take in your phones. Yeah, just on the side. Quick attendance. Anders? No. Caden?
Yeah.
Esther?
Yeah.
Hillary?
Yeah.
Jennifer? Jojo? Julian? Other Julian? Liam?
Yep.
Lucas?
Yep.
Mirhat? Mike? Mick?
Yep.
Where?
Yeah. Right here.
There you go. Oliver?
Yep.
Riley?
Yeah.
Vienna?
Yeah.
Zachary?
Yep.
Excellent.
Zachary.
All but Anders. Good. So, an atom. That's wrong. That's the wrong piece. Oh, there we go. Okay. What part of the atom is negative? Yeah. Electrons. I just realized I got all that set. I'm not asking random people. So I'm already displaying hand bias. Jojo, laptop away. And next one is what part is positive, Liam? Pardon? Positive nucleus. And overall, an atom is positive, negative, or neutral. Caden? Neutral. Because the protons should equal the electrons. So that's an atom. Which is it that can change if you're going to get something with a charge? Now, if I call on you, that's hand bias. I'm biased towards people that put up their hands. I'm going to ask, guess what it said? Julian Chan. Go. Pardon?
Oh, atoms can lose or gain electrons.
Electrons.
And they're called ions.
And they're called ions. So that is pretty much the definition of an ion. An atom that has lost or gained electrons. You could also change your charge by losing or gaining protons. Why can't they do that? Yeah. Confined to the element. It is part of it. I mean, you could, and then, but it's a nuclear reaction. We're not doing that. It changes fundamentally what it is. You can lose and gain parts of yourself, and you're still the same person. If you want to, if you want a diet plan, I can have you lose, I don't know, 10, 15 pounds, like that. Takes seconds. And still be the same person. All you have to do is chop off an arm and a leg or so, and then boom, you're lighter. However, and this happened in my biomedical ethics class in university, we were discussing the ethics of a variety of surgeries, heart transplants, lung transplants, and how it relates to consent and personhood. And then one person asked, what about brain transplants? And the professor says, well, obviously, that's not a thing because A, technically too hard. Also, if your brain is broken and you get someone else's brain, have you fixed your brain? No, that's like changing the number of protons. You are now the other person. Your brain is you. And then the person asked it again. It was clear they didn't get it. And then the professor, whose main teaching method, as far as I could tell, was sarcasm, made a series of very funny jokes. Funny to us, not funny to the students who they're towards. Brilliant, but not very nice. Does anybody know what these mean? Like if I write negative, positive. So I have a variety of shorthand I use from being in years in chemistry class and biology classes. And you write negative and positive all the time. So that's my shorthand. It is not an official shorthand. You can't use it in an essay or a standard abbreviation or anything like that. DNA is a standard abbreviation. You can use it anywhere. It's just like a word. But that one is not. That one is not a standard abbreviation. What is that one? Energy. So there's lots of energy going around. We use that. Negative, positive. What other ones have I seen? Oh, I use this one a lot because you have to write this a ton in chemistry class. What's that one? What word does that stand for? What word might you write a ton? Try and sound it out. Rickson. It's a reaction. Right word, go faster. Two new terms. We have anion and cation. So if you're a negative ion, you are known as an anion. If you are a positive ion, you are known as a cation. These may or may not be new terms to you. If you have trouble remembering them, I have a mnemonic that I used to use that seemed to work for me, and that is anions are negative. Anion, it kind of looks like the word, it looks like the word onion a little. And when you cut onions, they make you cry. And crying is negative. I mean, there's like 3 logical leaps in there. So that if that helps you, it's great. Also, cations are positive. Positive. Maybe that one will work better. I have no others. If you have one that works well for you, that's great. There was a hand over here somewhere. Yes?
I was going to say the cats have pause.
Oh, cats have pause. Yeah. Now, if you're negative, which do you have more of, electrons or protons? Hillary.
If you're what?
An anion or negative.
Wait, can you repeat the question?
Yeah. If you're negative or you're an anion, which do you have more of, electrons or protons?
If you're electrons.
Electrons. And then if you're positive, you would have more of
Protons.
Excellent. That's just to save space for the alligator teeth. Oh, metals and non-metals. We are going to go through and reintroduce. You did the periodic table last year and like introduced the families. We'll do that again, but as a quick review, I'm going to do it on this one because it's already sideways. Well, the other one has the colors. Maybe that'll be better. And rotate. Nice. Where are the metals? Like point with your hand. Where are the metals? No, don't point it there. Like point on the side. Like is it this, are the metals on that side of the periodic table? Everybody's pointing that way. Excellent. So it says metals. This is why this one's useful. But it's not just here. It's everything underneath here. Most of the elements are metals. So these are all the metals. These are all the non-metals. Now the one thing this colored one doesn't do, it's nice and fancy, is they didn't put in the semi-metals. So there's actually semi-metals in here because arsenic isn't quite a metal. It's not quite a non-metal. It actually does both sometimes. Silicon is a great one. It's got metal and non-metal properties. Carbon, which is near that line, can be both +4 and -4. So just so you know, things get blurry. Like most things, it exists on a spectrum. So there's really metallic things, there's really non-metallic things, or really, really non-metals. And then there's things that are like in between, and they have properties of both. But what do metals tend to want to be? And you can look at your charges. Do they want to be positive or negative? Positive. What do non-metals want to be? Negative. So do metals want to gain electrons or lose electrons? There's a common cognitive trick your mind plays, and I heard some of you fall for it. It wants to become positive. You are used to thinking that positive means more. So when I say gain electrons, your brain goes, yes. You lose electrons to become positive because electrons are negative. So you're losing more negative. So just make sure you're very careful with that. It's usually not too big of a problem, but I know that happens all the time. So the metals lose electrons, and become positive. And non-metals gain electrons to become negative. Perfect. Ooh. Currently, Julian, and Hillary are winning. You both all have you have one extra point than the rest of the class. That being said, you only have 2 points and everybody else has 1. Is anybody not done with this? Okay. Okay. I'm gonna now on the previous one that we just did. We just assumed the electrons and the protons were the same number because these were all neutral. But in the future, or like right now, not in the future, it's like literally right now, we're going to assume these can be different, and from that, we can get the charge. Or if I give you the charge, you can work backwards to the number of electrons. So if you have 6 protons and 6 electrons, you're a neutral charge. But if you have 13 protons and 10 electrons, what charge would you be? Who's going to tie up for the number of massive points? Mirhan. Pardon? Positive what? 3, yeah. Because this side is positive, that side is negative, so we have 3 more positives than we have negatives. Next one, Riley. Oh, sorry. I said next up and I didn't clarify. So for sulfur that has 16 protons and 18 electrons, what would the charge be? Negative number 2. Because we have 2 more electrons than the number of protons. You can always get the charge. If we were to put it in a formula, is equal to the number of protons minus the number of electrons. I don't tend to memorize this as a formula. I just compare positive and negatives, but I know some people they like their formulas. So if you like your formula, you just go 16 minus 18 is minus 2. 13 minus 10 is plus 3. 6 minus 6 is 0. Boom, 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 boom. And you can rearrange that formula any way you want. if you want to know the number of electrons, is equal to number of protons minus the charge. So let me double check that I didn't do something stupid. 16, ooh, yeah. What is 16 minus negative 2? 18. Minus the negative, you have to add it, so we do that. I did once teach Set 5 math in grade 9. We got a core group of students that couldn't add or subtract properly. They just been missed, and they're all new students. So they gave them to me. There's 5 students in the class. They passed Math 9 by the end, so success story. And then one time during the year, I walked in, and I just kept making really, really dumb mistakes. And Tyler, I won't say his last name because we're being recorded, said, Mr. Neufeld, we know we're here because we're not good at math. You're being affected by our dumb rays. And I'm like, Tyler, don't say that. Don't insult yourself. He goes, no, it's true. And then we had a little laugh. And so I went and I put tinfoil on my head to protect myself from their dumb rays. And they thought that was funny. And then a tour walked in. And then a senior administrator said, Mr. Neufeld, why do you have tinfoil on your head? And I was about, like, I didn't know what to say. And then the administrator did math. And so they're like, oh, it's for foil in math, learning brackets and stuff. First outside. And I was about to say yes when Tyler said no. It's to protect him from our dumb rays, and explained the whole thing. The positive message is that we didn't get another tour for the rest of the year. And if you're on an accident in the middle of the Malahat, Tyler might actually be the one who rescues you, who now does the ambulance up and down the Malahat. He did fine in math after this and did really, really well. So if you see Tyler after you've had your leg ripped off in an accident, say hi. Julie? Yeah?
Was he here for the career day thing?
Don't think so.
Because there was a guy with like an ambulance.
Oh, yeah, it wasn't him. No, different guy. Okay. We did lots of board models last day, so I don't want 4. I would like you to draw fluorine, but I want you to do the circle and stick. Circle and stick with, and I want you to do pairs. I want you to do the electron pairs correctly. So that's the ones like you learned in grade 8 where you made circles and oh, okay. You probably call them circle and dot. That make? Okay. And then for this one, I want you to draw the efficient. But I want you to do both because I want to check something on both. And because nothing is fun unless you get to do it together. Hold it, where? There it is. Whoa. We are. Oh. What? All classes. What? Have you hatched? Let's see. Toolkit. Oh God, it's taking a long time. Okay, I might just do it on here. Why are you taking so long? Oh, who did it? Does everybody here know about neverssl.com? Whenever the network doesn't work, you type in neverssl.com. What that does, if you haven't signed into the network, like you haven't properly logged in, it will force it to bring a splash page that says, welcome to Brooklyn College School, and you have to sign in. But if you need to sign in and you go to a normal website that has lots of security, they don't allow pop-ups, they don't allow redirects. They're so locked down, they won't let you sign in. Never SSL was made, it has no security. so that it will allow, and you can just use it to check.
New thing. Router should be like under Wi-Fi. Is yours
Yeah, there's some stuff happening. I believe the whole network's going to stop today at some point.
Again,
For them, but they're trying to fix it. Okay, Liam, you can go with any group you want. I want those two things for fluorine drawn somewhere on the board. Go grab your people. Get on up there. Go, gadget machine. Circle and dot. That's when you had the electrons on a circle and you went boom, boom. Oh, okay. Find a spot on the board with your partner. Liam, who are you joining?
Oliver.
Excellent. And you have to do it on the whiteboard. To the whiteboard. You can theoretically do it over here, although there's no pens back there. Both models. Okay. Did someone just say sigma? Apparently a sigma's more extreme than an alpha wolf, so I just assumed it was a furry thing. Remember to do your pairing in this circle and dot model correctly. Both models, efficient and circle and dot. Are you guys going to do it? Yeah. I want to see them all.
I don't know what the circle is.
Oh, well, here. Oh.
Is there a model that's just like
And you do the atom, not the ion. That's someone being very clever at adding charges. That is very clever, and I'll give you points for that. But just the atom, please. Just the atom. Okay. Once you're done with both models, you can have a seat.
You don't need to add charges. How many do you have here? Yeah, you missed
Have you figured out how to do the add us to the cluster? The
Are you not added to the cluster?
cluster?
I haven't called your name.
No, I'm on it, but like, so we can look on our phones.
Oh, no. I'm not going to worry about that until lots of other things are done, like my classroom. Sorry. Sure. Yeah. Yes. Is that it? Math, that's the time. What is that? Is that a minus in there though? Yeah. Time is 30 seconds minus 0 seconds. Oh, okay. Because I thought that was a 5, which is the same as that. And that confused me. Yeah, I would say your answer is only 168. Because you can only measure to that 168 bracket. Okay. Which means they should get the right number at 168. Everybody should be correct. Everybody should be correct. We're not asking for 4 decimal place accuracy. Well, maybe we are, but only once a day. That's what I would say then. Okay. Have you guys done the board? Are you comfortable checking your answer there? Yeah. Okay. Because I will get started here. Okay. I'm going to go through. Oh, ha ha! It's the boring model. Was that? I assumed it was a joke. There's no laughter going. Okay. Incorrect, correct, incorrect. Incorrect, correct. Correct, correct. Correct-ish. No, I said no ions.
Oh, there's both.
Yeah.
A
Don't.
little left or
No, you're not allowed secret knowledge. Correct, correct. So here's my pedantic, because this is going to come in helpful later, especially when we do Lewis dot diagrams. Because you're already doing it correct for all the other ones, which is weird. Like in the middle, you've spaced them out. But you didn't space them out for here, you correctly paired them. So when they run out of room, they have to be paired. How many spots fill in the first one? Two. So you can't put it there, you have to put them beside each other, because there's only 2 spots in the internet beside each other. Which is also somewhat of a lie, but it's a useful one. And for this one, same thing, you gotta pair them. It doesn't matter where you pair them. It's only a model. It's only a model. And those were done well. So, other than that, very good. And I'm being pedantic, because when we do valence electrons in Lewis dot diagrams, that will become more important. So, circle and stick, I will add mine on now that you've done it, but now I want every same group to go back up there and do it for the most likely ion, except for the cheater group that already did it.
Damn it.
If you want, and then did you redraw the entire model? Oh, you could have just altered your. You could just alter your original diagram. Just add on to it if you want, or you can redo it. That's fine too. Also, indicate the charge. So tell me the charge. How about you do one of them on there, the new one with the ion? What did you add? Electrons or protons? Or take away? You added electrons, charge or electrons? One negative. So if you add an extra electron, what charge will it be?
Oh, you shoot it for this one as well?
I was
There we go.
I had a 1 in the answer. I don't know.
You're not chewing gum, right?
Wait, why are you changing all of them?
Yeah, my fault. Might as well.
It's literally a reminder, you're not allowed to chew gum in this building. Oh my God, Miss Allen will kill you. Because we do not, as of yet, have gum in the carpet. You're not actually allowed to chew gum in any building on campus, including your dorms. Because too many people have gotten gum in the carpet. Just so you're aware. You have to chew it carefully outside for 3 minutes and 40 seconds, and then carefully spit it into the nearest receptacle. That's the only way you're allowed to chew gum. Yeah. Just so you're aware. Okay. 8. Nobody indicated the charge. What's the charge?
Minus
Negative 1. They indicated the charge. They indicated the charge. And I didn't say it right away, so that probably confused things. Whenever we do indicate the charge, we do so with brackets. So if we wanted to indicate the charge, we'd go like this, and we put it in giant brackets, and we say -1. However, chemists are lazy, and they go, I don't feel like drawing brackets, so they don't draw that bracket, and then they just draw that part of the bracket, and they just assume the rest. And the reason I show you that is one student once asked me and said, beside the charge, Mr. Neufeld, why do you always draw a giant number 7? That's not. That's to indicate a giant brackets, and it's just sort of assumed that those brackets are there. They're just hidden. But just so you know, it's not a giant number 7. Yes?
Does that mean that for a very efficient ion diagram, you could do like the 9 protons, 10 neutrons, and then 2, 8, and then that little bracket thing in the middle?
That's fine. Yeah, absolutely. Sometimes this is useful because we're going to do Lewis dot diagrams where you don't draw it efficiently because it's a spatial model to show how things bond. So this is really useful for spatial models. But this is really useful to communicate things like number of valence electrons really quickly. So to change these, you just did it up there, so I'm going to do it here for the people who aren't here so they have a recording, and that is -1. And then we have this one, we change that to an 8, and that is -1. And let's double check. Now that I said for the people who aren't here, there are 2 people not here. Are we live? Yeah, we're live from downtown Mill Bay. Excellent. What?
2 views.
2 views! Well, they're probably both me, going back separate times.
What if Anders is watching right now?
Oh, that's it. If Anders is watching right now, the secret code is pomegranate. And that way, if he's listening, he tells me that later. Bonus points.
Tell him.
Yeah.
Wait.
What? Maybe. But you can watch in the health center because it's live. No excuse. Okay. This is very similar to the table you just did. Except in this table, the electrons and the protons were the same. But in this table, because you may or may not have a charge, they might be different. They are the same if it's 0, but they won't. Sometimes they'll tell you the charge. You got to get the number of electrons. Sometimes they'll tell you the number of electrons. Sometimes the charge, the number of protons. For the symbol, include the mass number. They've also got it here, and we include the number of neutrons in there so that you can use the actual mass, not estimated from atomic mass. There's no atomic mass on this table. This is all mass number. So you don't have to guesstimate it. Fill it in. And while you're filling it in, I'm going to go get the demo ready. Because it is 12:41 and I do not want you to miss it. You will need your periodic table probably pulled out each and every class.
This one and this one are the same.
Oh, you've ripped apart your periodic table.
Yeah.
You will need different pieces of it. The only reason why that's bad is if you lose parts of it. I will get extras for this done. That number on the top, we go all the way back. This way. Oh, you just hang it down. Aha. How was it in here? Just so I can reference it. And that was one of the things, where's the symbol? The number on top, that number That is the mass number. That's the protons plus neutrons. And that should be the same as your mass number column. Does that make sense? And if they include a number on the bottom, we often omit it because if we know the element, we know what it is. But if they include one on the bottom, that's the number of protons. That's the same as the atomic mass. Does that make sense? Okay. Why don't I as well work through the first one so everybody has an example I just realized. What's the atomic number of beryllium? I don't have my periodic table. Beryllium.
I think there might be a problem with beryllium. Maybe the number of electrons, by the way.
What? What? Atomic number 4. Okay. And there is not a problem with the number of electrons. Because if you have 4 electrons and 4 protons, what's your charge?
Then you made a mistake with Francine at the bottom of this chart.
I'm willing to bet you I did not.
We put protons is 87 and electrons is 86.
Yep.
That's -1.
Yep. What charges if it's got 86 and 87?
Doesn't beryllium have a...
Not beryllium, that one.
Beryllium doesn't have any charge.
In this particular case. So if it doesn't have a charge, you're talking about its atom, not its ion. So that just means an atom of beryllium. Like beryllium metal. As opposed to beryllium chloride, in which case it will have a charge. So some of these may have a charge, some of them may not because they haven't reacted yet.
So some of them are ions and
Some of them are ions and some of them are atoms. So this isn't a table of ions, it's a table of both. So you have to determine it from the number of electrons or the charge, trying to figure out which those are. Does that make sense now? Okay. How about we do? Now, you're going down. Can you do the top 1, top 2 across? So I just want to see that you can do every type of column. I'll come back. Because when you do across, you're focusing on the same elements. And all the pieces. Going down probably feels efficient, but then you have to relook up all the information about that element. If that makes sense. No. However, it is 4. Why? There you go. You are off the race. You were doing lots of things. You were doing some things. Oh, you were as well. You're going to do it. You're doing it by column. Do it by row.
I'm just doing like the ones.
Okay. Well, if you do it by row, you're focusing on the same element. You're looking at, the mass and all the things. And you don't have to re-look it up every time. It'll be a little bit more efficient, but you are welcome to do it anyway. And you look like you are off the races. You are working away. And how are you? Okay. Which 2 columns should be identical? Yeah, excellent. So this one, beryllium is 7 from that 7. That's the mass number. So for carbon 14, why'd you write 7? Or is that a 14? Oh, okay, you're 7. Oh, you even include a little cross with the German speak. Well done. Oh, well done. I always do that on mine as a habit.
Is it the same?
I think it's way better. People get always confused with ones and some. So the mass number for this one would be 14. And then how do you get neutrons from mass number to proton? Perfect. Now, if you had 0 charge and 6 protons, you would in fact have 6 because they should balance it at 0.
Mass number? It tells you it's 63 here.
Yeah, that's where the mass number is.
That's what it's 64. It could be like 50% chance for sure.
Now, I would recommend going by row because then you're focusing on the same element and then you know the mass number, number of protons, and you can put it everywhere. Yep. plus 2. Yeah. Not 8. 4. So yeah, that's plus 2, and this would have to be 2 less. Because the protons are positive. And that is a thing that your brain and my brain, everybody's brain, because we say, oh, positive, I must add more. No, positive means we took electrons away. Yep. Now, while you're doing that, I am going to say,
85 minus 3.
oh, 1 second after that.
49. 87. Minus 12. Chromium 18.
Okay. If you could put away your notes, get out a pencil, an eraser, and a calculator for your quiz, is something I will say on Thursday. But for now, I'm going to hand you a practice quiz. The questions you get on Thursday will not be identical, but it should give you a feeling of what you should be able to do. So this is homework, but I will post the answers so that you can check them. We are not going to go over it in class, but that way you can make sure you're on the right track. So check the Google Classroom for details. And the whole put everything away, get ready for a quiz probably woke you up, so you're welcome. Ooh, if you want to use a calculator, you'll need to bring it on quiz day. All right. Why? You should pass it to the next person. They're not all yours. This is practice for homework. Next day.
No, it's 2.
Next day, I am going to do a calculator check. Everyone, I would like everyone to arrive with a scientific, I'll accept graphing, but a scientific calculator, not your phone. And I will let you know if it's good enough for Chem 11 or Chem 12. It has to be able to do logarithms. You can get away with pretty much everything that can do scientific notation in chemistry 10, but you might as well get one that's good for Chem 11 if you think you're going to do that, and also serve you well in physics. You cannot use your phone for a calculator in class. If you don't have one right now, I'll let you. But I want you to get used to the calculator. One of the most common things I see in chemistry 11 is someone uses their phone for all their calculations. Then they use a brand new calculator for the test, and they don't know where the buttons are, and so they use it incorrectly, and then they don't get wrong answers, and we have to assume they don't know. So I want you to start using a calculator. They're very cheap. I think during back to school sales, I saw the cheapest was $4.88. They're usually around $15 otherwise. They're available at the school store. If you decide to order one on Amazon, next day you just show me your order, that'll be fine. I just want to make sure you're going to get one. Okay, given the time, please put down everything. Pencils, erasers, put everything down. Stand. Come on up. We're going to put you in some goggles and show you that. Okay, what time is it? It is 1:02. You are allowed to go. We are 2 minutes after the junior lunchtime. Thank you very much. If you're not quite done this, please finish it for homework and study for your quiz. Your quiz is on Thursday. I will post the answers to the practice quiz, so you will be able to mark it yourself.
Classification.
I am on duty Tuesday afternoons if you need extra help. And I will now stop the live stream.